Okay, next we're going to justify, and this is the hardest part. This is what you need to be able to get up to an 8. And I'm going to justify two ways. I'm going to justify geometrically, and then I'm going to justify algebraically. Alright, so let's just look at first a couple of differences of squares to see what's happening. So let's look at 4 squared minus 3 squared and see why that's equal to 7. Now the key is looking at this expression. We have 4 squared and 3 squared. We should be able to make some squares and figure it out. So here's 4 squared. Okay, that's 4 by 4, so that's 4 squared. And if we subtract 3 squared, we can try to draw a 3 by 3 square within it, and then we'll subtract it. And then we can see what we're left over, what's left over. So notice that we'll have 7, right? We'll have 7 left over, and there's a 4 there, and a 3 there. Okay, so that's why when you do 4 squared minus 3 squared, it's the same as 4 plus 3, because you're going to have a 4 plus 3 left over. You can see that for other size squares, like let's say we have a 5 by 5 square. So 5 by 5 square. And so I'm going to do 5 squared minus 4 squared now. So this is 5 by 5. And here we have a 4 by 4 square that I'm going to subtract. Okay, and then we're left with these squares in green. There's 5 and there's 4 over here. So that's 5 and that's 4. So if I have 5 squared minus 4 squared, I get 5 plus 4 left over. Okay, so that's how it works. And the key is when you're justifying, you want to draw the nth diagram. In this case, maybe I'll call it the bth diagram. So just justifying. Okay, so let's start off by saying if we take b by b square, okay, oops, square. So let's draw the b by b square. So here's b by b, and subtract b minus 1 squared. Okay, so remember originally we have b squared minus then b minus 1 squared, and then that difference is going to be this. So anyway, so we do that. When we subtract b minus 1 b squared, b minus 1 squared, so let's draw on the b minus 1 squared. Okay, when we subtract that, we are left with, this. We're left with two little rectangles. We're left with this rectangle and this rectangle here. Okay, let me actually shade that in green, do some color coding. So we're left with two little rectangles. Okay, and what are the size of those rectangles? Well, this one is b minus 1 and this one is b. Okay, we're left with this. So we're left with b plus b minus 1. Okay. So this is why. B squared minus b minus 1 squared equals b plus b minus 1. Okay, so this is justifying your rule. We showed it with the bth diagram. Okay, next we're going to be doing this algebraically. So let's try it algebraically. So remember now, I start with b squared, alright, and then I'm subtracting b minus 1 squared, and we're saying, well, let's just start with that, and then we're going to work our way down, and we're going to get our result of b plus b minus 1. So let's try this out. So if we start with that, now this is going to involve a little bit of algebra. So we can write this as b minus 1 times b minus 1. Okay, then we can multiply this out using the distributive property. So we have b squared minus b squared minus b minus b. Negative 1 times negative 1 is positive 1. Okay, we can simplify what's in the brackets, and we have minus 2b plus 1. Okay, so this negative here means everything inside the brackets is going to be negative, or you can think of it as a negative 1 and use the distributive property. And we're going to get b squared minus b squared plus 2b plus 1. Okay, so notice this cancels, right? So we just get 2b plus 1. And also notice that our rule is, remember our rule is you just take b plus b minus 1. That is also 2b plus 1. Okay? Actually, it should be 2b minus 1. Oops, I made a mistake. Let me back it up a bit. This negative 1 times that should give you negative 1. So that was 2b minus 1, and they match. Okay? So this justifies that your rule is correct. It proves that your rule always works.